Okay, so I just went through this entire video, and for some reason the program that I'm using to record it didn't record. So I've gone ahead and left up the entire picture, and I'm going to go ahead and walk through it again, talking through it and kind of making some more notes so that you can see how I got to everything that I got to. So this video is kind of the kicker for about the last 4 or 5 videos, and it's called the 2x2x2 Hecksher-Ohlin Model. And the reason it's 2x2x2 is that there are 2 resources, in this example land and labor, 2 goods, in this example cotton and wheat, and 2 nations, the US and the rest of the world. So I've gone ahead and we're going to make land red and labor this light blue. So this can get kind of confusing, and hopefully the color coding will keep it clear. The next assumption that's made in this Hecksher-Ohlin world is that there are constant returns to scale. And so that's what I was kind of demoing up here. And what that means is that if you double the amount of inputs you use, you double the output. So let's say that I was using 1 unit of labor and 1 unit of land, and I got 1 unit of cotton. If I doubled those inputs to 2 units of labor and 2 units of land, I would have to get 2 units of cotton for there to be constant returns to scale. So this simplification, because we're doing all of this graphically, this assumption isn't important, but it's important when you do this proof mathematically, which we're not going to do. But I just wanted to put it there so that you understand kind of what world we're talking about, or what we are simplifying down to get these assumptions. So these next 2, or these next 3 really, all lead to what makes this model really, really interesting. So these 2 go together and are the analogy for this one. They're kind of analogous to one another. So this assumption is that the technologies used to produce the 2 commodities, in our case cotton and wheat, are different. So they have different production functions. And so I just want to illustrate that point. I just said, for example, 1 unit of cotton needs 1 unit of land and 2 units of labor, or 1 unit of wheat needs 2 units of land and 1 unit of labor. So the assumption that the production functions are different leads to the conclusion that one good is labor intensive and the other good is land intensive, or one good is intensive in one factor of production and the other good is intensive in the other factor of production. But in this example, these would be labor and land, because those are the 2 factors that we are talking about, land and labor. Okay, so in this example, cotton is labor intensive and wheat is land intensive based on these production functions. And I want you to go ahead and just check that on your own. I've done this all ahead of time, so I encourage you to go check it, but you will see that that is true. And these different intensities, one good being intensive in one factor and the other good being intensive in the other factor, are what make this entire model interesting. So because of this, we get these bowed out production possibilities curves. And that's what I was doing up here in this kind of bright pink, bright purple. So in the Ricardian model, you remember our production possibilities curves were straight lines. And that meant that when trade opened up, one country specialized all the way in producing one good and the other country specialized all the way in producing the other good. And that's not very realistic, because that's not what we see out in the real world. We don't see like the US only producing high-tech goods and the rest of the world producing all of the food that we need, for example. We see that the US produces a lot of high-tech goods, but that the US also produces some lower-tech goods. And so that's why the Hecksher-Ohlin model is so interesting. So in the linear case, you go ahead and get a kink in your production possibilities curve. It bows out, but it doesn't do so nice and smoothly all the time. It kind of has just this kink right here. And the opportunity cost in this first part is much different from the opportunity cost in this second part. And so what you can see is that in this first part, to produce 1 more unit of good X, you only have to sacrifice a little bit in good Y. You only have to sacrifice a little bit in good Y. But over here, to produce 1 more unit of good X, you have to sacrifice a ton of good Y. So the opportunity costs are obviously different as you are in one side of the kink or the other side of the kink. But what's really interesting is not if you use a linear model, but if you use a nonlinear model. And that's why we're doing this entire thing graphically rather than mathematically. So nonlinear production possibilities, or production functions, normally take the form of Cobb-Douglas production functions. And so I've gone ahead and put two examples here. The first one is, let's say the amount of cotton that we produce is equal to the square root of the amount of land times the square root of the amount of labor. And then the amount of wheat that we produce, because these two have to be different, remember, is equal to the cube root of the amount of land that we produce times the 2/3 root, times the amount of labor that we produce or use as an input to the 2/3 power. So if we were to have production functions like these, we would get a production possibilities curve that was bowed outward and smooth, like this. And so why this is interesting is that the opportunity costs are constantly changing as you produce more and more of good X. As you produce more and more of it, it gets more and more expensive relative to good Y. And that's why it's interesting. So now we're going to go ahead and get down to the Hecksher-Ohlin model and see why it's interesting. So I wanted to go ahead and highlight one more time before we get down there that we are going to go ahead and say that the U.S. is land abundant and that wheat is land intensive. And I may not have gone over this assumption too much because it is just like this assumption. But what this guy right here says is that one nation is abundant in one resource and the other nation is abundant in the other resource. So basically, it's just that the commodities are different, the technologies used to produce the commodities are different, and the nations are different. So in this example, the U.S. is land abundant and the rest of the world is labor abundant. And I want to just highlight one more time that we're going to do labor in blue. Cotton is labor intensive, so cotton will also be blue. And the rest of the world is labor abundant, so we're going to make the rest of the world this blue. Then the U.S. is land intensive, is land abundant, we're going to make land red, so the U.S. will also be red. And then wheat is land intensive, so we're going to go ahead and make wheat red. So now we're getting down to the Hecksher-Ohlin model. And where we start is just by drawing these production possibilities curves. So just drawing this guy. And what we see is that because the U.S. is land abundant, it can produce, its ratio of wheat to cotton production is greater. The amount of wheat that the U.S. can produce divided by the amount of cotton that the U.S. can produce is greater. So let's go ahead and actually write this. The amount of cotton that the U.S. can produce over the amount of, flip-flopped. The amount of wheat that the U.S. can produce over the amount of cotton that the U.S. can produce is greater than the amount, the ratio of wheat in the rest of the world over cotton in the rest of the world. Because the rest of the world is labor abundant and cotton is labor intensive, so the rest of the world can produce a ton of cotton, and it can still produce a little bit more wheat than the U.S., but not a bunch. So that's all that there is to say about these production possibilities curves. The next thing is to go ahead and introduce an arbitrary demand line that is the same for both nations. So this arbitrary demand line, I just went ahead and made it like y is equal to x in both examples. And where that crosses the production possibilities curve is where that nation is going to produce without trade, with no trade. And what that says is it allows us to determine the opportunity cost or the relative prices of those goods in that nation without trade. So I went ahead and said that the slope of this imaginary, or not imaginary, but the slope of this derivative for this situation is -1. I just said, you know what, let's just go ahead and say that it is. So then the opportunity cost of producing one more unit of wheat means that we have to sacrifice 1 unit of cotton. So one more wheat means we have to sacrifice 1 unit of cotton. And that's because the US, well, we'll get to that in a second. So for the rest of the world, because the rest of the world is so good at producing cotton, because the rest of the world is labor abundant and cotton is labor intensive, and the rest of the world is so good at producing cotton, to produce at this same point, to produce 1 more unit of wheat, it has to sacrifice 2 units of cotton. It has to sacrifice 2 units of cotton. And you can see graphically how that really kind of plays out. Because the slope of this derivative, the opportunity cost, is so much greater in the rest of the world that producing wheat is really, really expensive for them relative to their production of cotton. And so now we've kind of laid the foundation that wheat is really expensive for the rest of the world to produce and cotton is expensive for the US to produce. We've laid the foundation for opening up trade. And that's what this says down here, is that the price of wheat relative to the price of cotton in the rest of the world is super, super high. That wheat is expensive. Wheat is expensive in the rest of the world because they're so good at producing cotton. And wheat is cheap in the US relative to the production of cotton, not because the US is super good at producing wheat. The rest of the world can actually produce a little bit more, but because the US is so bad at producing cotton compared to the rest of the world. So let's go ahead and see what would happen if we opened up trade. Well, it's kind of intuitive to say that the rest of the world will produce extra wheat, the rest of the world will produce extra cotton and will trade it for the US's extra wheat. And so what happens is we keep this demand line exactly the same, but the rest of the world can choose to produce at a point out here. And the US will choose to produce at a point down here. And then the US will trade with the rest of the world. The US will trade wheat for cotton so that the US can go ahead and get outside of its production possibilities curve, and the rest of the world will do the same thing. It will get more wheat than it could produce on its own in exchange for its extra cotton, so it will get to be able to consume out here, which is better than it could do all on its own. So I'm not going to go through, I'd have to have numbers to go through exactly where they end up, but it is the exact same concept as in the Ricardian model. And so now I'm going to go ahead and just jump to the major conclusions. The US, when trade is opened up, the US is going to produce more wheat than it was before. And that's seen by this point right here. Then the rest of the world is going to produce more cotton. And that's seen by this point right here. The US is going to export wheat and the rest of the world is going to export cotton. And I want to highlight that the nation will export the good that was intensive in the factor that it was abundant in. So the US was abundant in land and wheat was land intensive, so the US exported wheat. The rest of the world was labor abundant and cotton was labor intensive, so the rest of the world is going to export cotton. Finally, the price of both goods falls and both nations are better off. So that's kind of the happy ending. The last thing that I want to say is that it doesn't lead, that the Hecksher-Ohlin model, the Hecksher-Ohlin model doesn't lead to total specialization. Lead to total specialization. And my pad is kind of wigging out on me, I apologize. To specialization, because of these curved production possibilities curves. because the opportunity cost of cotton continues to get super high up here. So the rest of the world specializes, but doesn't specialize completely. So I think that covers it, and I apologize that I wasn't doing all of this out as I was talking, but I felt that it was just way too difficult to go ahead and erase all of this and start over from scratch just because my computer kind of wigged out on me. So hopefully that makes sense. Ask me any questions you have. I hope that was clear, and I will see you in the next video.